Okay, we're going to take a look at nonlinear systems today. So it says solve the system by substitution. So if you recall, substitution indicates that we're going to replace something with something else. So those two y's are the same. So I'm going to take this part and I'm going to substitute it in for that y. So our equation is going to say x squared plus x minus 1 equals negative 2x plus 3. And a solution to a system is always where the equations actually intersect each other on a graph. So we know that this graph is going to be a quadratic, and we know that this graph is going to be a linear function. So we're trying to figure out where on the graph do these two intersect. Well, because we have a quadratic, we have to equal 0. So we're going to add 2x to the other side. And we get x squared plus 3x minus 1 equals 3. And then I have to subtract 3 to the other side. So x squared plus 3x minus 4 equals 0. And once it's equal to 0, we know that we can factor it. So we got to ask ourselves what multiplies to a negative 4 but adds to 3. So 1 and 4 and 2 and 2. Well, if I do 4 minus 1, that's going to give me 3. So I have x minus 1 and I have x plus 4 is equal to 0. So then we have x minus 1 equals 0 and x plus 4 equals 0. Add 1 to both sides, so x is 1, and then subtract 4 to both sides, so x is negative 4. So we know that it is going to intersect two different times. So our u is going to be like this, and then we're going to have, so we'll have two intersections. One of the x intersections is going to be at 1, the other one is going to be at negative 4. So now what we have to do is we have to plug each of these into our original functions to figure out what y is. So I am going to go to this one because this is going to be an easier function to plug into. So we have y equals negative 2x plus 3 as our function, and we found x to be 1 and x to be negative 4. So if I plugged 1 in, negative 2 times 1 plus 3, that means y is going to be 1. So that means it's going to intersect at the ordered pair 1, 1. And then if we plug negative 4 in, we're going to get negative 2 times negative 4 plus 3, and we get 11, which means this is going to also intersect at negative 4, 11. So those are our two solutions. Now when you solve a system by substitution, sometimes you can get no solution, and that would be when we, for example, you could have a graph like this and then like this. These two functions would never intersect each other, so that would be a no solution. You could also have one solution where we would have this, and then let's say like it would intersect here and it just intersect one time. So you can have two solutions, one solution, or no solution. So let's look at a situation where you would end up with just one solution or no solution. So again, we're solving a system. These two are the same. So I can take this function, and because y is equal to it, I can plug it in for y. So we end up with x squared minus 3x minus 2 equals negative 3x minus 8. I don't know why that is there. And then because it's a quadratic, we need to get it equal to 0, so we're going to add 3x to the other side. And in this particular problem, those cancel, so we have x squared minus 2 equals negative 8. And then because it's an x squared, we can just isolate that by adding 2 to the other side. So we have x squared equals negative 6. And then to undo a power of 2, we would square root them. But at this point, this is going to become an imaginary number. And we haven't learned about imaginary numbers yet. And you actually don't need to know how to do imaginary numbers. So if you end up with an imaginary number where you're taking the square root of a negative number, then you end up with no solution. Which means if we were to graph these two functions, they would not intersect. So for example, it's going to go like this, and then it's going to go like this, and they just don't ever intersect. So this would be a no solution situation because that is not possible for right now. And that is how you solve a system of nonlinear systems by substitution.